Hello guys. As you may know, we recently attended the Camp Quirky festival. It was a festival for self-builders, and what an amazing time we had there. While we were there, I was invited to do a couple of insulation workshops. I did one workshop on the Saturday and one workshop on the Sunday. I was absolutely blown away by the response and the amount of people that attended. But what I thought it would be a good idea is if we recorded the workshop, so for all of those people that didn't manage to get to Camp Quirky, you could see the insulation workshop for yourself. There's a lot of information in there that I haven't covered previously in my previous insulation videos, and I think you'll find it really useful. So we've taken that footage from the Sunday workshop, edited it, and here are all the best parts. First of all, let's talk about how heat is transferred. So heat is transferred in three ways. Conduction is the first way, and that is heat is transferred when two objects or two materials are touching each other and one is hotter than the other. Heat is transferred from the hot object to the cold object. The reason being, the hot object, all the molecules inside it are all excited and jumping around, and the cold object are not. So that's got more energy, and that transfers that energy from hot to cold. That's conduction. The second method of heat transfer is convection, and that happens in a liquid. That can happen in a water, a liquid or a gas. And to explain how that would happen in your van, if you think of the cavity that's formed between the outer steel skin of your van and the inner steel skin of your van, if you didn't insulate that void, what would happen is the outside skin of your van could be, say, at 5 degrees, quite cold. This steel would be fairly cold, and the air that's inside there would also be cold. Cold air generally falls, so the air inside would be falling to the bottom of your van. And then inside your van, it could be quite warm. It could be sort of room temperature, 20 degrees C, if you've got heating on in there. So through the ply lining or whatever you've got, tongue and groove, the air that's in this side of the van is going to be warm. Warm air rises, so the air is going to be rising in here. And what you'll get is you'll get a circulation will happen, because some of these voids are up to 100 mil thick, 4 inches thick, and you'll get air circulating, and that is by far the best way of transferring heat. That will transfer heat much quicker than if you've got two materials touching each other. So this is what we want to try and avoid. So we want to insulate these spaces to try and avoid this convection. And then the third way that heat is transferred is by radiation. And radiation doesn't need any medium to transfer through. I'll give you an analogy. If you're standing in the sun like it's nice and warm today and you've got the sun on your face, what you're feeling is radiation. It's infrared, it's a light source basically. So radiation from the sun will travel through the vacuum of space, through our atmosphere, and it will hit your face, and that's what you feel as warmth. So that's the third way that heat's transferred. And then later on in the talk, what I'll do is I'll give you some methods in which you can combat the radiation that's hitting your van, when you're parked up in the summer. All materials have the ability to conduct heat, but at different amounts, and this is called thermal conductivity. And this basically relies on the density of the material. It's given a Greek symbol, lambda, and you'll also see it referred to as the K value. And this is the level of thermal conductivity. And the units for this are watts per metre K. And what this means, watts is the amount of energy. A metre is 1 metre thick of material. So all of the lambda figures and the K values are based on a 1 metre thick piece of material. So we can do a direct comparison between all these different materials by relating the K values, because it's all done to a standard. So what you've got, in effect, you've got 1 metre of material, you've got a 1 degree difference either side, and then it's the amount of watts that will pass through 1 metre thick of that insulation if you've got a 1 degree difference between either side. So this is the standard that they use to tell you how good an insulator it is. Let's just throw up a list. I've looked online and pulled off all the list of various common materials, and I've pulled off all of their K values, their thermal conductivity values. And these are all the K values. So these are all the thermal conductivity values for all these different materials. And if we look down the bottom of the list here, so we see we've got a lot of metals here, very dense materials, and they're really good at conducting heat. So we've got steel here, which is the steel wall of your van. That's got a thermal conductivity value of 50. So basically 50 watts would travel through a metre thick piece of steel if there was a 1 degree difference either side. And then we've got aluminium here. So aluminium's a really like a superconductor, 236 watts per metre. And you know, things like processors on computers, they use aluminium as a heat sink because it's so good at conducting heat, it can get rid of the heat really quickly. And then if we travel up, as the numbers get smaller and smaller, you'll see we get sort of less dense materials. We've got cork, neoprene, which is a rubber material, and then we start getting into the insulation materials. And then we can see we've got some insulation here. This is a mineral wool insulation. This is a polyisocyanurate or PIR board. So on here we can see that the mineral wool insulation has got a thermal conductivity of 0.044, so it's a very small amount. And then the PIR board is right at the top here, and that's actually got a thermal conductivity of 0.022. So that's an excellent insulator, that PIR board. It's very, very good. So we use these K values to compare these different insulations. And when you're looking to buy your insulation, this is the figure that you want to look for. So when we look on packaging, we see here it says thermal conductivity. And you'll see there, this was actually that recycled plastic that I've got there, and this has got a thermal conductivity of 0.044. So it's the same as this mineral wool insulation. So actually this material and this material are the same value in thermal conductivity. Now you will also see insulation given an R value, and a lot of people talk about R values. I'll explain the difference between the two. The K value, as we've just said, is based on a metre thick piece of material. Now the R value is a level of resistance, and the only difference between the two is the R value takes the thickness of the material into the equation. So to work out the R value for an insulation material, R is equal to the thickness in metres divided by the lambda figure, or the K value. So let's just work out what the R value would be for this PIR board here. We know that's 50 mil thick, so in terms of metres, that's 0.05. And we know from our list that we had before, the PIR board has a thermal conductivity of 0.022. And we get an R value of 2.27. And sometimes you'll see that on packaging, you'll see the R value is given instead of the K value. And that is just because it's relative to the actual thickness that they're selling you. If we was to do the same calculation for a 100 mil thick PIR board, this value would be double, because it's twice as thick. If we do the same for the recycled plastic, just to compare the two, this recycled plastic insulation is 100 mil thick. So on the top of the equation, 0.1, 100 mil in metres is 0.1. And the thermal conductivity of that is 0.044. So again, if we calculate the R value for that, is 2.27. Now you'll notice that we've got the same level of resistance, but that plastic insulation is 100 mil thick. So that's telling me that this PIR board is a far better insulation. In fact, it's twice as good, because I only need 50 mil of it to get the same level of resistance as I do with 100 mil of the plastic loft insulation. So space is critical in your van. You know, there's small space anyway, so you want to make sure that you're insulating with the best product that you can, because that way, with the lowest K value, you can then get away with putting a small amount of it in and get the equivalent insulation to, you know, sort of 100 or 150 mil of insulation only off of a 50 mil board. So when you're looking for your insulation, and what I've done in my van, wherever possible, I use that PIR board. So on the floor of my van, I've got PIR board on the floor because it was nice and easy to lay. I've also got that 50 mil PIR board in the ceiling, in between the ribs of the van. I've used it for the flat side panels as well. And then just in the awkward areas where it's difficult to use that, then I've used the recycled plastic insulation and I've just poked that into all the voids, just because it's easier to work with. Obviously, going to the extreme, on the top of the chart, you may have noticed that was one item on there that was better than anything else. And that's this substance called Aerogel. Now, it's a fantastic insulator. It was designed by NASA for the Space Shuttle, and I've actually got a piece of it here. And a lot of people say, well, why don't you insulate your van with that? That's got to be far better than anything else you can get. I mean, this stuff is really a super insulator. I could put my hand on top of that with a blowtorch underneath and I wouldn't be able to feel a thing. But the thing with this, obviously, is the cost. I managed to buy this little piece, but this costs £100 a square metre. And I worked out if I was to insulate my van with this, it would be fantastic as an insulation, but it cost me about £3,000 to insulate my van. And then lastly, briefly, before we go on, I just want to talk about this stuff, which seems to be all over the internet. A lot of people are using this as an insulator. I couldn't find anywhere on the internet a K value for this material. It's sold as an insulation. All of the packaging says it's insulation, but its thermal properties are really, really poor. Its thermal conductivity value is almost nothing. I've actually calculated it and it's 0.12. You know, it's very, very small. The reason being, this is aluminium foil. We've already established when we looked at the materials list, aluminium is a superconductor. You know, it can conduct heat really easily. So this aluminium foil is literally only 0.2 of a millimetre thick, so it's no thickness to it. So that's going to conduct the heat really fast. So that's not going to offer any insulation properties at all. And then sandwiched in between there, you've got a very small air bubble. So you've got about 4 millimetres of air. Now, air is a pretty good insulator. If we look on here, air is right up here. It's got a thermal conductivity of 0.026, so it's quite a good insulator. But the value doesn't change with thickness. Air is one of these things where the thicker the void gets, the worse it gets almost, because then you start getting convection currents, which is a really good way of heat transfer. So it's one of these things where the thermal conductivity of air doesn't change. The smaller the cavity, the better. The bigger the cavity, the worse it gets. And when you've got a very small cavity like that, which is only 4 mil, the heat is going to transfer across there very quickly. So why this stuff was developed, and the main reason this is installed in buildings, is for its reflective purposes, because this foil is an absolutely excellent reflector. This will reflect 97% of the sun's radiation. And what they do in buildings and that, obviously, they use it as a radiant reflector. So it's installed within the structure of a building so that the sun's rays coming through the building will reflect back out. And that's really its main purpose. The other purpose is it's a very good vapour barrier. Foil is completely impervious to water. So no water or no moisture will get through this foil. So I have used this in my van, but I haven't used it as an insulator because its thermal conductivity properties are rubbish. I've just used it purely as a vapour barrier. And then we'll come on and I'll discuss about the problems with condensation and so forth, and how I've used this to combat moisture travelling through my insulation and causing condensation on the inside of my van. When you're looking around at various insulation products, and I've taken some photographs, you'll see these labels printed, and the label that's printed on this piece here. And hopefully what you should be looking for is this little lambda symbol, this little Greek lambda symbol, or you want to be looking for the K symbol. Some manufacturers will print both the thermal conductivity value and they'll also print the R value, but really you want to be comparing the K value because it takes it all back to that metre thicker material, so you can relate every piece of material on a common level base. What some manufacturers do with the R value is they'll try and confuse you by giving you an elevated R value. And what they'll do is they'll actually publish an R value where their material has been installed in conjunction with a lot of other materials. And they're saying, oh yeah, if you use our material in a loft space with tiles, joists, plasterboard and everything else, you'll get an R value of 16. But it's false advertising. That's not the R value of the insulation. That's the R value once it's combined with all those other materials. And a classic example of that is when they advertise this material, because they won't tell you the R value for this either. What they will do is they'll publish a list of R values when it's combined with all these other different building materials. So you really have to be wary that you're getting the right information. So if you always look for the K value, you know it's a standard for that particular material at 1 metre thick. And then, you know, there's no way they can be confusing you for that. Stick to the K value when you're looking for your insulation and get the K value as low as you can, and that'll be the best insulation that you can put in. What I want to do now is just discuss the pros and cons of all these different insulations, because there's a few things to take into consideration when you're selecting your insulation as well. Not only is it really going to be thermally efficient, you know, what are the benefits or what are the pros and cons of actually using all these different insulations? So I've broken them down into 6 sections. The first one that we've already discussed is its thermal properties. So we already know that we need to get a low K value. We want the best insulation because we only want to put a small amount of it in our van and we want it to work really well. And then second, I've considered the ease of installation. Most of your vans, I've got a Mercedes Sprinter, so it's very curved on the walls. None of them are really sort of straight edges. So when you're using this type of material, it's a solid board, it's very rigid. So it's difficult to bend into the curve of your van. And then you've got lots of little intricate pockets. So you spend a lot of time carving it with a knife and moulding it, and it's very difficult to use in that kind of application. It's perfect for your floor, because it's nice and flat, and it's actually very strong. So you can actually just put it on the floor of the van. You can put your subfloor, your ply lining on top of that, you know, and it's very solid. So it's no problem for that. And also I've used it on the roof of my van as well. The roof has got a very slight curve to it, but what I've done is I've just put a nick in it with a knife, if you like, and just being able to just bend it just very slightly. Or you can even just build it up in sections and put it on like a lobster back. And then obviously the plastic insulation and the mineral wool and all of these wool-based materials, they're really easy to work with. You know, this can be moulded to put into a little small cubby hole somewhere. All the pockets at the bottom of my van, I've used this type of insulation or a mineral wool insulation, and all the pockets at the top I did. And all the ribs and the structural parts of your van, I cut strips of it and fed them through there and pulled them all through so that it will all full with insulation as well. So this is a lot easier to work with. And then thirdly, you want to consider the health risks, because there are some insulations that are out there that aren't very friendly to us. Glass fibre is one that's a classic, because the glass fibre insulation can be an irritant, so it can make you itch. Obviously when you're installing it, if you breathe any of the glass fibre in, it can be a real sort of irritant for your throat. I mean, I suffer terribly with it. I can't go anywhere near it. I just get a really bad hacking cough with it. And it does irritate me, it makes me itch. So it's one of these things where, you know, it's not very practical to use. And I don't see many people using glass fibre in vans, to be honest. There's much more sort of friendly products to use these days. Also chemical insulations. I see some people using spray foam, which is a liquid form of that PIR board. And you can also get spray foam, like expanding foam in a can. It's an excellent insulator. It's got the same thermal properties as that rigid board. And then obviously you can spray that within all your voids and so forth. But you just need to be aware that there's got a chemical propellant in here. So you need to use it in a well ventilated area, and you probably need to be wearing a mask as well, because you don't want to be breathing this stuff in. And then for a short period afterwards, there is some what they call off-gassing as well. So the chemical propellant will come out of the insulation over a period of time. So for a couple of days in your van, it still will smell a bit funny. So That's maybe one of the considerations with that. And then the fourth thing we want to consider is fire safety. You might want to put an insulation in your van that won't, combust in the case of a fire. That mineral insulation that you see at the bottom there, this is a Class 1 rated product. This is completely fireproof. And so is this PIR board, funnily enough. They've now manufactured it so that it's got a Class 1 fire rating. Some of the older boards would combust and give off, horrible chemicals, but the modern boards now are completely fireproof. Obviously, if you're looking to use expanded polystyrene, what you get packaging in for your TV, when you've bought your TV from Dixon's, or showing me Curry's, or something like that, then we can look, expanded polystyrene is quite a good insulator, 0.03, so it's very good thermally, nothing wrong with using it in your van, but then obviously it's very poor in terms of fire safety. If you did have a fire in your van, it would burn readily and it will give off toxic fumes, so maybe that's a consideration. The fifth topic we might want to consider is it eco-friendly? Obviously everybody's concerned with climate change and being able to recycle materials, and I think us as van lifers in our community, that's probably one of our high priorities as well. We want to use recycled materials in our vans. This material here is an excellent example of that. This is made out of recycled plastic bottles, and this is at the top of the news at the moment, obviously, because we're trying to reduce the amount of plastic that we use and find a way that we can reuse those wasted bottles. And it's got brilliant thermal properties. The other good thing about this as well, and we were talking earlier about health risks, is this is not an irritant. This won't cause any itchiness or anything like that. It's also water repellent. So if there's any moisture that gets on this, it will just repel that water. It won't soak it up like a sponge. So this has got some good properties. And then the last thing we want to consider is the cost. And I think as we've seen, a lot of vans, particularly I did my van, and I was trying to do it on a budget. We originally did look at buying an actual motorhome, but when we realised it was going to cost us £50,000 to £60,000, I thought, hang on a minute, no, we're not going to be able to do that. So we built our van because we could do it cheaper. I mean, that bale of recycled plastic insulation was £18 for a roll, and I think I used 3 rolls of that in just the cavities of my van. And then this PIR board, for an 8x4 sheet of this board, is £25. And again, I used 3 50mm thick boards and 3 25mm thick boards because I had a slightly thinner board on the floor. Just for over £200, you can really adequately insulate your van, and to a really good thermal property. In the industry, when we were doing construction jobs, the insulation contractors that we would use to insulate buildings, I knew that there was these available, and these are called stick pins. And our insulation contractors used to use these to put on galvanised ductwork. So we'd design an air conditioning system for a commercial building. There'd be huge galvanised ductwork, and then we needed to insulate it because obviously it was cold. We didn't want it to sweat. And how we'd stick the insulation onto the ductwork is with these. They've got an adhesive back. There's a little peel off. And then you stick that onto the steel of your van. And believe me, these really do stick. They will not come off. If you get this somewhere where you don't want it, you are going to have a problem getting it off. Once that's on there, there's no way that is coming off. And then what you do is you take your PIR insulation and you just push it onto the spike. So if you imagine that's the roof of your van, that's already fairly secure as it is. That's not coming off. And I've only got one on there. I think I only used 4, one in each corner for each board, and it was enough to hold it in place. And then what you do then is you get one of these little caps. It's like a barbed cap. It's a one-way thing, and then what you do is you push that on top of the spike, and then that now is not going to come off. You'd have to break that to get that off. So that's going to hold that really securely. And then lastly, all I do is just bend the pin over, and then I just put a bit of foil tape on there just for a bit of protection. Once we've stuck the pins on, we foil tape over that, And then what I then do is then I put a moisture barrier over the whole of my insulation. So I've insulated with the PIR board, I've put the plastic wool insulation into all the awkward places, and then what I do is I've used this Reflectix as a moisture barrier, and I've lined the whole of my van with it. So I've covered all of the floor, the walls and the ceiling, and then I've foil taped all the joints so it's completely sealed. I've used this aluminium foil, and anywhere there's a joint I've put the foil tape all over everything. So when you look inside the van, before it was ply lined, it was absolutely covered with foil everywhere. The reason we do that is because there's a problem when we're living in a van. It's a confined space, it's very small. Us as humans, we breathe out moisture all the time. We sweat to regulate our own temperature, so we're giving off moisture through our skin. We're also cooking in the van, so even boiling a kettle or boiling a pan of vegetables, you've got water moistures coming into the van via that. And then also if you're using propane or gas as your heating source, one of the byproducts of the combustion of propane is you get lots of water. The chemical equation for propane is a hydrocarbon, C3H8. So that's propane gas. Now we combine that with oxygen when we're burning it. We get heat as a byproduct of combustion, but what we also get is carbon dioxide and H2O, which is water. So we've got 4 different ways that water's going to get into our van. So it's going to create quite a moist air in there, you know. And then what you're going to find is that's going to come out and condensate on any cold surfaces in your van. Here in the UK, the weather is pretty cold generally most of the time. So the outside skin of your van is going to be fairly cold. So if we don't do anything to protect the van internally and stop that moisture from getting to the cold steel of the van where it can condensate, that's when we're going to get the issues. And that's why we installed a vapour barrier. So we've got the steel of our van, we've got the ply lining or the tongue and groove or reclaimed pallet wood or whatever you're putting as the inside lining of your van. We've got the insulation, whether it's PIR or the mineral wool, in between there. Fill in the void so that stops any of the convection. And that's given us great thermal properties. So that's stopping the heat or the cold from being transmitted into our van. So that's either keeping our van warm in the winter or keeping it cool in the summer. It works both ways. And then lastly, what we do is we put our vapour barrier on top of the insulation on the warm side. And then what that does is that prevents any of that moisture that's in here. Let's say for instance in the winter time it's maybe 1 degree C outside, it's really cold. We've already established that the steel wall of our van is a good conductor. It's 50 watts is the K value for steel. So that cold temperature is going to be transmitted through that steel really easily. And the temperature inside here is going to be pretty much the same on the inside surface of your steel. If we're nice and warm inside here, let's say 20 degrees, and we've got moisture in there because we're breathing, we're cooking, we're using propane. What we don't want is we don't want moisture coming through this insulation so it can condensate on the cold steel of the van. So we put a vapour barrier there, an impermeable barrier to stop that moisture getting through our insulation and to stop it condensating on the wall of our van. And that's the reason why we do that. And we make sure that that's completely sealed as best as we can. Tape all the joints, tape it floor, ceiling, make sure it's completely watertight, and then you won't have any issues inside the walls of your van with condensation because none of that moisture can get in there. Now I want to explain to you what's actually happening and how is condensation formed and what can we do to try and combat it. And this will also help those of you who've already built your van. You may not have installed a vapour barrier, so there's a couple of ways that will probably help you to lessen the effect. It's not going to prevent it because you still will get some condensation, but the vapour barrier is the key to not getting any condensation at all. This is a psychometric chart. This gives us the properties of moist air. So along the bottom here we've got temperature in degrees centigrade, and then up the side of the chart is the moisture content. And this is the moisture content in kilograms per kilogram of dry air. So basically what that means is it's the amount of kilograms of water that's in a kilogram of air. And the density of air is about 1.2 kilograms per metre cubed. So roughly speaking, it's about a metre cubed of air, and that's about a kilogram. So 1 metre cubed of air weighs 1 kilogram. So if we've got a temperature of about 5 degrees, we come up the chart, and these lines here, these red lines, represent relative humidity. And you'll hear when you've had the weather report, you'll see they'll say it's going to be 20 degrees and 60% RH, or 60% relative humidity. And that relates to the amount of moisture that's in the air. And as the temperature change happens, relative humidity changes as well. So at 5 degrees C, we come up to 100% saturated, so 100% RH, 100% relative humidity, and we come across here and we can read off a value 0.005. So when the air is 5 degrees centigrade, a metre cubed of air will hold 5 grams of water, so it's quite a very small amount. And at that point it's fully saturated. So let's have a look at a higher temperature, let's say 22 degrees. And this can, as we can see, we can go up a lot further with this. This can hold a lot more moisture at a higher temperature. And this is actually 15 grams of moisture in 22 degrees. So if it's warmer in your van, that same volume of air can hold 3 times as much water before it becomes fully saturated. So it makes sense then to keep the inside of your van warm, because that warm air will be able to hold a lot more moisture in suspension. It won't be fully saturated, and you're not going to get condensation forming inside your van. I'll give you a simple example. You're driving along a cold morning, you jump in your van, start it up, you get all that condensation and mist on the windscreen of the van. First thing you do is you turn the heater on and you turn the fan on. And then what you're doing is you're heating that air up, and you're effectively drying out the air. You're reducing the relative humidity. That warm air can hold a lot more moisture, and that is what clears the screen on your, in the morning when you start your van up. And it's exactly the same principle when we're living in the van. If we can keep the van warm, that air is going to hold a lot more moisture, and then you're going to get far less condensation problems in the first place. Let's just take a typical temperature in the van. So let's just say it's 20 degrees, and we'll say it's 50% relative humidity. So we'll come up here. So we've got a condition in our van, 20 degrees centigrade, which is a nice comfortable room temperature, and it's 50% relative humidity. Now as the temperature in the van drops, say in the evening, as it cools down, the temperature's dropping, so we're moving this way along the temperature chart, but the moisture content is staying the same. We're not doing any cooking or anything like that, so we'll just assume that the moisture is the same. But what's happening is, as that air cools down, the relative humidity is increasing. So we're going up 50, 60, 70, 80, until we get to this point, and then that air is fully saturated. It can't hold any more water. And this point is called the dew point. And it's at this point where we'll start getting condensation appear. So if we look at the temperature, it's roughly about 10 degrees C. So it was nice and warm in our van, it was 20 degrees, we were nice and comfortable. The evenings got cold, the van temperature's dropping, and as soon as we get down to about 10 degrees C, we're going to start seeing condensation appear on the windows and things like that, because that air can no longer hold that quantity of moisture in suspension. It's got to come out somehow. And it's like on a cold day when you get clouds forming, the colder the temperature drops, that air cannot hold that water any longer, and that's why we get rain. It comes out as condensation, or it comes out as rain, because it becomes fully saturated. And the same thing's happening inside your vehicle. So to combat that, the best way is to keep the van warm. Now I've got a heater in mine which has got a thermostat. So at night time I just turn the thermostat down to about 15 degrees,
and I just leave it on tick over. It doesn't use a lot of fuel at all, but it just keeps the inside of the van above that dew point temperature. And then lastly, as well as keeping the van warm, another way that you can combat condensation in your van is to make sure you've got adequate ventilation in there. We've got 2 roof fans front and back in ours, and at night time we just leave them cracked open about 1 inch front and back, and it just allows that air to circulate through. And what that's doing is the air in your van is becoming fully saturated because you're breathing out, you're cooking and things like that, and you're just adding moisture and a lot more moisture to it. So by putting that ventilation in there, you're bringing in air which is probably only 50% humidity. So you're diluting it and then getting rid of that saturated air, and you're bringing in air which is probably drier. And we find the combination of a little bit of heat and a little bit of ventilation, we get absolutely no condensation issues overnight at all. When I'm parking up at night, what I try and do is, you'll have all seen those classic shots where you open up the back doors of the van and watch the sunset. There's a good reason for doing that, and it's a simple way to remember it. When your back of your van and your rear doors are facing the sunset, your van is pointing due west. And then in the morning, the front of your van is pointing due east. So that's where the sun's going to rise. So first thing in the morning, when you've got a little bit of condensation on your cab and on those cold windows, you're going to get that radiant heat from the sun directly on your windows. And you'll find in the morning that that will clear your windscreen in no time at all. And it really will help to heat up that cab area, which is by far the greatest sort of heat loss in your van. You'll get that radiant heat from the sun beating on the windscreen, and that will instantly warm up the cab of the vehicle. That will bring it above this dew point, and that will dry out all that condensation. One of the other things that people ask as well is, we insulate because it's cold here in the UK. I've had lots of people say, yeah, should I insulate my van? I'm living in Australia, or I'm thinking of travelling to the desert or hot places. Is the insulation going to work in a hot environment? Absolutely, yes, insulate your van. The thermal conductivity of all these materials works equally both ways, whether it's hot or cold. Heat will transfer, as we discussed earlier, from a hot space to a cold space. So if it's hot inside your van and cold outside, you'll get heat loss. And then conversely, if it's hot outside and you want to keep it cool inside, you want to reduce that heat gain. And by insulating your van, that will stop that heat from coming through into the inside of your van. And to give you a simple example of that, your cold box. You get a nice summer day and you're going for a picnic and you've got your cool box full of beers and salad, and that box is insulated, usually insulated with something like a PIR or an expanded polystyrene foam, and that's preventing the hot, warm air in the summer from getting into your cold salad and warming up all your food. So it's definitely worth insulating for both types of environments. One of the biggest sources of heat gain in your vehicle is your windows. That solar radiation that we talked about earlier, it has like a greenhouse effect, and the sun's rays will come through the atmosphere, they'll come through the window of your van, and they'll heat up all the objects in your van. So they'll heat up the dash, they'll heat up all your furniture, and then that will then give off heat into the inside of your van. So the best way to combat that is to put blinds up, either external blinds or internal blinds, to prevent that radiation coming in through the glass. And what we've got, you can get them externally, or we've got these internally. And these are a stick-on blind, and we're using the properties of this Reflectix, if you like, because as I've already discussed, this is an excellent reflector. It reflects 97% of the radiant waves. So on the inside of our screens, we've got this nice foil on here. So that's going to prevent any of the sun's rays coming in through our windows on a sunny day, and that's going to help to keep our van really nice and cool. These ones are like a dual purpose because they're insulated as well. So we do get a bit of thermal properties off of these in the winter. So when it's cold outside, these will give us a little bit of protection. And they simply just suction onto the windows. And a full set of these, I think I bought a set of these off eBay for the front screen and the 2 side windows. I think it was about £38. So they're not very expensive. So I think in summary, space is critical. You want to put the least amount of insulation that you can in. So you want to use an insulation that has got a very low K value. So that sort of wraps everything up. Have you got any questions? Does anybody want to?
What is it that only takes half an hour?
Ah, yes. during when I was building my van, and you know, I'd sort of nip out to the workshop, and I'd say, or Lou would ask me, well, how long are you going to be? I said, I'm only going to be half an hour, and then invariably I'd be out there all day, you know, and it'd become a bit of a catchphrase. And then every time she said, how long are you going to be? No, I'm only going to be half an hour, and I'd be out there all day. And then for Christmas, she got me this T-shirt. So, yeah, thank you. And I have, if you are interested, I have got some T-shirts for sale by the van. That's it. Thanks very much.